Hello students, this video lecture is extension of projection of lines. In the previous video lecture of projection of lines, we have seen the concept and probability of placing a line in different positions. Okay. We'll see a few problems. We'll try to draw a few lines with the help of few solved problems. Now what is the probability we have considered in the previous lecture, or different ways of positioning a line? For example, number 1, when a line is perpendicular to HP and parallel to VP. Number 2, line is in a reverse way, perpendicular to VP, parallel to HP. Similarly, number 3, parallel to both the planes, HP and VP. Number 4, inclined to HP, parallel to VP. Inclined to VP, parallel to HP. Number 6, inclined to both HP and VP. In the previous lecture of projection of lines, we have seen these conditions. I'll take a separate lecture to make you understand better, because this is a bit tricky and a bit confusing. We'll see that in the next lecture. But for today's lecture, what we see is we'll try to solve these problems. Okay. A question is given to you, how to solve the problem or how to draw that particular solution. That we'll see. Fine. Again, which is important, you need to imagine a lot of things. Try to concentrate. Again, we'll consider a horizontal plane and a vertical plane, the way we have seen in a previous lecture. Fine. Now there we have seen that a line, when it is parallel to both the planes, we have considered some above distance, some in front distance. When it is perpendicular also, some above distance, some in front distance. That is conventionally we have taken few dimensions. Okay. Whereas in this case, what we try to do is we'll try to take a question. We'll take a question. First question, I'll try to write the given data. Let us frame a question first. Like a line AB of 75 mm length. I'll try to write the given data. Okay. I don't write complete question. A line AB, I'll try to take the content out of that particular question. AB is 75 mm given, which is placed at a distance of 10 mm above the HP, 12 mm in front of VP. 10 mm above, 12 mm in front of VP. Above HP, 10 mm. This is the indication of above for our understanding, for my understanding. Okay. In front of VP, 12 mm given in the question. A line AB of 75 mm, which is placed at a distance of 10 mm above, 12 mm in front of VP, which is perpendicular to HP and parallel to VP. Perpendicular to HP, parallel to VP. Draw its projections. That is a question. Draw its projections. Fine. If that is the case, what do you need to do? Draw an XY line. Place these two dimensions. 10 mm above, draw one locus. 10 mm. 12 mm in front, draw one more locus. Some infinite distance for our understanding. Fine. Now these two got justified. 75 mm need to be drawn perpendicular to HP. When it is perpendicular to HP, true shape can be seen from the front. True shape can be seen from the front. When it is perpendicular to HP, from the front, true shape is visible. So which will fall on VP, which is above XY line. Fine. So from this point, I'll try to draw a line of 75 mm. 75 mm. Then I'll try to take a projection onto the top. Let us darken the required one. Now AB is visible. I'll try to darken AB. This point is also visible. Now thing is, we need to darken now. We have darkened already, and we need to give notations. If this is line AB, which is point A, is this point here point B? That you need to think. Now if this is a position, this is A, this is B. So true shape is visible. So you need to mark something like this. Top end is A prime, bottom end is B prime, because it is front view. Here from the top you could see only A, B is not visible, keep it in bracket. This is the front view projection, top view projection. Okay. Other than this, you also need to give dimensioning of that length, which is 75. This is how you need to draw solution. Number 2, a line AB, I'll try to write the given data. Listen to my question. A line AB of 75 mm length, a line AB of making an inclination of 45 degrees with VP. Let us consider, whenever a line is making inclination with VP, I'll consider it as phi for our understanding. Phi. Phi 45 degrees nothing but with VP only. If it is theta with HP, okay, theta 45 degrees nothing but line is inclined with HP. If phi means it is inclined with VP. Okay, AB 75 mm, inclined 45 degrees to VP, parallel to HP obviously. Okay, and position at a distance of 10 mm in front of VP and on, the question may be something like this, in front of VP and on HP, or else in few cases you don't even consider this particular data in the question. If that is not the case, if something is not given, you need to consider it as the line is touching the plane, horizontal plane. But here in this case he said it as, the data given it as on HP. If it is on HP, it need to touch the XY line. That is also important. Now I'll consider one XY line. Now AB 75 mm, 45, 10 with in front of VP. When a distance is in front of VP, what happens? If some distance is in front of VP, for example this is the same line, in front of VP means the projection is going to be on HP will rotate 90 degrees clockwise. That will come down below the XY line. Means this inclination will also come below the XY line, because whenever it is inclined to vertical plane, the projection is going to be on the horizontal plane. As the horizontal rotates 90 degrees clockwise, what happens? It will come up below the XY line. Then what I need to do, I have to in front of VP means below the line, a distance of 10 mm need to be marked, locus, consider a locus. Fine. Again, at a distance of 10 or 12 mm away from the dimension, make a mark. Try to place your line now of 75 mm, maintaining inclination of 45 degrees. With respect to this horizontal, make a mark of 45 degrees and draw your line 75 mm and take the projectors onto the XY line. Why onto the XY line? Why not above XY line? Because he has given it as on. No above distance is given. If no above distance is given, you are not supposed to maintain any distance. Okay. Now darken the required line 75 mm. Now wherever these two projector lines meeting with XY, darken that distance also. Okay. Now this is your top view, A prime, B prime. If this is A prime, this is going to be A. This is going to be. He may ask you in the question, find the reduced length distance. Then you need to measure this particular length with your scale. Then you need to write reduced length is equal to some distance in millimeters. This is important. Now these two projections need to be darkened with HB pencil. Other things need to be drawn with 2H pencil. Okay. Sorry, we made some mistake here. Prime has to be given to front view. This is wrong. B, this is also wrong. A, top view always indicated with AB or XY or whatever the letter or number given. Whereas in case of front view is indicated with a prime. Okay. This is the reduced length. Clear? That is a question. Now let us consider one more question. Given data, a line AB of 80 mm length, placed at a distance of 15 mm above the HP and 12 mm in front of the VP. A line AB of 80 mm length, placed at a distance of infront distance of VP. Infront nothing but obviously it is meant for VP only. In front of distance of, let us consider 50. Okay, this is the data given. Now what is the position now? A line AB of 80 mm length, placed at a distance of 15 mm in front of VP, 12 mm above the HP, and it is parallel to both the planes. Parallel to both nothing but VP and HP. We have only two planes. So obviously it is going to be vertical plane and horizontal plane. Fine. Now for this particular question, I'll draw XY line. I'll try to place in front and above distances. In front will always come below, which is 15 mm. Draw one locus. Above, which is 12 mm. Draw one more locus. These two are justified. Now the line is parallel to both the planes. If line is parallel to both the planes means the position is going to be something like this. Parallel to HP, parallel to VP. Parallel to HP, parallel to VP. At a distance of 15 mm with VP, 12 mm with HP. The position is here. So when I view from the front, the projection is going to be on VP. From the top, the projection is going to be on HP. As we know, HP will rotate 90 degrees clockwise, it will come below. So both the ways, I mean front and top, we could see the true shape of the line. 10 mm away from the dimension line, I'll make a mark again here. From here, I'll consider 80. From here, draw a line of 80 mm. Then take a projector line below until it go and meet with the locus 2. Darken this line also. The projection need to be darkened always. This is ultimate projection, final projection. Okay. Now you need to give notations. Front view always notated with A prime, B prime. This is A, B. Now these two both are true lengths only. Because it is parallel to both the planes, you could see true shape from the front as well as true shape from the top. This is the case. Number 4. Given data. A line AB, or else why AB always, will consider it as a line PQ of 45 mm length. A line PQ of 45 mm length is inclined 35 degrees to HP and parallel to VP. Inclined 35 degrees to HP. Now when it is inclined to VP, the inclination going to be below XY line, and we notate it as phi, this angle as phi. If it is with HP, theta is equal to 35 degrees. Okay, line PQ of 40 length is inclined to HP, is inclined 35 degrees to HP and parallel to VP. That's it. This is the question. No above distance is given, no infront distance is given. Draw its projections. How to do? Simply draw an XY line followed by no above distance is given, no infront distance is given. Start somewhere on XY. I'll consider this point. When it is inclined to HP means the projection is going to be on the vertical plane, is always above the XY line. Above XY line always going to be vertical plane, below it is going to be horizontal plane. For all the problems, not only for this problem, for all the problems whatever we have solved till now, if it is a first quadrant problem, above XY is VP, below XY is HP. Okay. From this point, draw a line of 35 degrees inclination, length of 45 mm. Okay. This is a line PQ, P prime, Q prime of 45 mm. Then when I view from the top, I could see a reduced length which is unknown to us. So try to take a projector onto XY. Now this distance, I'll try to draw with some other color. This is the true length given in the question, and this is the reduced length. P prime and P are sharing the same point. P prime and P sharing same point, and this is about Q. Because no infront, no above distances are given, this is the case. For example, for the same question, we'll try to consider some above distance of 10 mm, some infront distance of 5 mm. If this is the case, again what we need to do, simply draw an XY line, consider above distance as 10 mm, infront distance as 5 mm. Let us make it more. Draw one locus here, draw one more locus here. 10 mm away from the locus, make a mark. Start drawing your 45 degrees inclination, 35 degrees inclination with a length of 45 mm. 35, 40. Okay. Then draw a projectile line onto the second locus. Now wherever these two meet, darken that line. Now try to darken with a HB pencil. 1, 2. This is more important. If you don't darken it, then the evaluator don't understand. Projection need to be darkened always, which is your elevation. Fine. Now in this case, this becomes P prime, this becomes Q prime, this is P, this is Q. This is reduced length, true length, reduced length, true length. Now this distance is equivalent to this distance is also, PQ is also equivalent to PQ. Only thing is we have considered above and infront distances, that's it. In all the cases, all the problems whatever you have drawn, try to focus. Now here below XY is always infront distance, this is above. Remember, we are dealing with first quadrant. If we are dealing with first quadrant means below is always infront distance, above is above distance, above HP. And XY, above XY line, it is always vertical plane, below it is always horizontal plane. Whenever you draw an XY line, above going to be vertical plane, below going to be horizontal plane. Remember, this is very much important. Whatever you are going to draw above the XY line, that is going to fall on vertical plane. That is the reason we are drawing it above the XY line. Whatever you are drawing below XY line, that is going to fall on horizontal plane, VP, HP. This is important. So this is above, this is in front. Don't get confused like above, below. It is not below, it is in front. This is more important, these 2 points. Similarly, this is also, there is no above distance given, so this is above, this is in front, vertical plane, horizontal plane. Similarly for all. Fine. So why that indications? Now here this is the proof. Horizontal plane, vertical plane. There is a line AB of some 80 mm. The projection is falling on VP. Okay. Now have a look. If you consider this as XY line, above is vertical plane, below is horizontal plane. That is the reason whenever the projection is falling above means it is falling on VP. When it is falling below XY means it is falling on HP. As we rotate HP 90 degrees clockwise, it will come below the XY line. That is the case actually. Okay. So we have covered few problems which are very much simple to understand. Practice more and more this kind of problems. If you have any queries, you can comment on the box below given. Okay. In the next lecture, I'll try to focus more and more on a line inclined to both the planes, which is very much important for your externals. Okay, this is all for now. Thank you.